And the next section is key topic 18, equipment faults. So keeping with the equipment theme, we're going to wrap up the sub-element with this equipment fault. So we'll be 3/4 of the way through, 18 out of 24. There's a code regulation on suspension of transmission. Transmission must be suspended immediately upon detection of a transmitter malfunction and must remain suspended until the malfunction is fixed. And there is an exception for the immediate safety of life or property. In that case, you stop the transmission after the emergency is passed. So if something is wrong, my little illustration here says the transmitter induces a hum noise. So basically you're disrupting communications throughout the whole area. So basically it's telling you to suspend it immediately and fix the problem. Makes sense to me. Do we have any questions on that? Yes, we actually have 2 questions on that. First one, if a ship's radio transmitter signal becomes distorted, what do you do? Do you reduce your transmitter power? B, do you use minimum modulation? C, do you cease operations? Or D, do you reduce the audio amplitude? Okay, your transmitter's screwing up. What do? Do you just turn down the power or adjust the modulation or adjust your amplitude? No, you guys are both right. You cease operations immediately. And you might get the report from someone else saying, your signal is distorted and splattering. So immediately stop transmitting, switch to a dummy load, investigate the problem. Most importantly, stop transmitting. And the second question, under normal circumstances, what do you do if the transmitter aboard your ship is operating off frequency, overmodulating or distorting or splattering? What do you do? Your transmitter is messing up. Do you A, reduce the low power, B, reduce audio volume level, C, stop transmitting, or D, make a notation in the station operating log? Yeah, too bad all the questions in this section are not as forthright. So hopefully your coin flip on what type of questions appear on your exam. It'd be nice to get one like this and move on to the next one. But instead, there's a few others. Okay, it does say it's illegal and dangerous to operate the transmitter that's outside of specs. You must be constantly aware of your behavior, of its behavior, and repair any problems ASAP. A high-frequency SSB station may sometimes go into distortion if the battery supply voltage to the equipment is slightly low. So your battery levels should be kept correct. Stop transmitting until you solve the problem. If you notice a radio dial light dimming on modulation peaks, it's likely that your radio equipment is going into distortion. So some little clues. All right, now the next three, I don't think I've done a very good job at explaining them, but let's take a look at them. Basically, I'm showing you that voltmeter, ammeter that we saw earlier. I like the prior picture better. I might swap it out here at some point. What would be an indication of a malfunction on a GMDSS station with a 24 volt DC battery? Okay, we're getting into a little bit of troubleshooting here. These are equipment faults, so sometimes it's difficult to read a book on how to troubleshoot. You almost have to use some deductive reasoning, and a lot of times it is to eliminate the other the wrong answers in effect. So let's say this is a proper reading on your voltmeter and your ammeter. Your 24 volt DC battery, should read 24 volts, give or take 10% or something like that. A constant 30 volt reading on the GMDSS console voltmeter. So you got a 24 volt battery in there. I mean, it is hooked up to a charger, but for some reason you're reading 30 volts. I would certainly say that there's probably some malfunction there, either in your indicator or perhaps in the battery or the charging system. So far, that one's not a bad answer. B, after testing the station on battery power, so you're in effect unplugging it and then just going on your backup power, which is the battery, the ammeter reading indicates a high rate of charge and then declines. So this is the ammeter here. Okay, now we just unplugged it from the AC or the charging source, so you're probably going to see a rapid decline. So that's not really a malfunction. If you kept it plugged in, it may continue to show a charging rate, which is in effect what the ammeter is showing you. C, after testing the station on battery power, a voltmeter reading of 30 volts for a brief period, followed by a steady 26 volt reading. So is that a malfunction? The fact that it starts out at 30 volts, but that was just briefly, or is that like some sort of surge that happened because you turned it on? Maybe there was a little pent up energy while it was sitting, waiting to be engaged. So it quickly gave a 30 and then it dropped to a 26. Now 26 isn't 24, but it's a lot closer than 30, I believe. So I would feel better if it read 26. Matter of fact, I would like to see a little bit over 24. Or none of the above. So are none of those malfunctions, or is the first one where you're showing a constant 30 volt reading, is that the malfunction? Apparently, that station, if it's operating on a 24 volt DC battery, should never show a charging voltage greater than 26 volts DC, which makes not a malfunction. That's a function. If you do show a constant 30 volt reading on the voltmeter, shut off the equipment immediately. It's likely the charging system has lost regulation. There's like a voltage regulator that's attached to the charging system where you can adjust how much voltage is going to go into it before the charger in effect automatically shuts off. So apparently the charger isn't shutting off. And if you have NiCad batteries, that could cause a total battery failure. Being in an overcharged situation like that for so long. Shut down the generator or the charging system to prevent a potential 24 volt DC battery system wipeout. And these batteries are not cheap, so do your best to try to preserve them. If it's operating at 30 volts and it's not supposed to, disconnect it and fix it before you wreck your battery, and all of a sudden the captain has to explain to somebody why he has to spend $3,000 for a new 24-volt battery. All right. Here's the next one. I should end that last poll. Real good. All right. I'm like I said, my explanations of these last few questions are not going to be the greatest. This one here, basically, I'm just defining some of the words that pop up in these options. So let's see. Which of the following conditions would be a symptom of a malfunction? Again, we're looking for malfunctions. We're, in effect, troubleshooting. Again, there's not going to be a textbook that tells you exactly how to do it. You just have to use a little bit of common sense and, rationalize it or eliminate the wrong answers. So we're looking for a symptom of a malfunction. So we notice something about the system, and that's going to indicate a malfunction. So it's a symptom. It's a 2182 kilohertz radio telephone system that must be reported to the master and then logged appropriately. Now, we did see earlier that equipment malfunctions must be immediately reported to the master. So we're looking for a malfunction in the equipment. I'll launch the poll. All right, so A, much higher noise level observed during daytime operation. Now, I did kind of explain a little bit here in the second sentence. The composition of the ionosphere at night is different than during the day because of the presence or the absence of the sun. You can pick up some radio stations better at night because the reflection characteristics of the ionosphere are better at night. And you might notice that if you're driving across the country at all, you're getting radio stations at night from Chicago, New York, really far away. And so basically you're going to expect, because the sun's out during the daytime, the ionosphere doesn't function as well. Basically you're going to hear more interference or noise during the day. So is that a malfunction? Probably not. Certainly, if you're going to report to the master you heard some noise during the daytime, they're probably going to look at you like you're not up to speed. B, no indication of power output when speaking into the microphone. Sometimes you don't know. Let me move my screen over here. Okay, you can see my microphone indication when I'm talking into it. Now let me hit the mute button and see what happens. Yeah, you could see all of a sudden there was no indication. In that case, my mute button was on. So presuming you checked your mute button, no indication of power output when speaking into the microphone could be a malfunction. C, when testing a radio telephone alarm on 2182 kilohertz into an artificial antenna, the distress frequency watch receiver becomes unmuted, an improper testing procedure. And I did define artificial antenna above. It's a device that simulates all the electrical characteristics of an actual antenna, except that the energy supplied to it is not radiated. It is not sent outward. It is usually dissipated as heat in a resistor. And in C, they're saying that the distress frequency receiver became unmuted. I just noticed the word receiver, so I think they threw in receiver so that otherwise you might have to report to the captain or the master that I accidentally sent out a distress alert. Yeah, you're probably going to have to own up to that. But if the mute is on the receiver, well, that's not really going to, you can't hear them, but you're not like muting you didn't unmute the transmitter. But still, that's an improper testing procedure, but no foul, no problem, not a malfunction. It looks like a little bit of a human error, actually. You're looking for malfunctions that have to be reported to the master. Perhaps errors have to be reported to the master also, but that's not what the question is asking. Or D, failure to contact the shore station 600 nautical miles distant during the day. Well, we already saw that radio waves do travel further at night, but I believe with VHF we're talking 60 miles, and then medium and high frequency that might bounce off the ionosphere. I think that was like 100 miles or 200, maybe double at night. But 600 nautical miles, yeah, don't don't presume that that's a malfunction, especially if that shore station is operating under reduced power. So that's not going to be considered a malfunction. So far it looks like the only one is possibly the microphone not indicating a power output. And that is the correct answer. All right, so on a Marine SSB transceiver, depressing the mic button and speaking into the microphone will show a modulated power output. Yes, we'll see that right on the screen. Even with the bad antenna, your transmitter will continue to put out a few watts. However, when you're speaking into the microphone and you detect absolutely no power output, you either unmute yourself or report to the master of the ship, or if it's possibly a problem with your microphone. And you might have another microphone you could swap out and quickly determine whether or not that's the problem. All right, and the last question. I hope. I did the same. No, it's not the last question. It's the second from the last. All right. Which would be an indication of proper operation of an SSB transmitter rated at a 60-watt PEP output? Okay, here's what happened to the cease communication. Yeah, this one's a little tougher, isn't it? But again, we're basically, going through it, and some of the terms that we may not be familiar with, I'll go ahead and try to explain a little bit. So far, we indicated a SSB transmitter. I think we dealt with a single sideband. SSB is a modulation type used to transmit information. So we saw SSB. It's rated at 60 watts PEP. So if we're going to see a power rating of something other than 60 watts, perhaps that's going to be an indication of a malfunction. Or in this case, they're actually asking for an indication of proper operation. PEP is usually it's ways of measuring sine waves. As the radio wave goes through space, it has a peak, a high peak and a low peak, and PEP, I believe, is peak to peak output, but peak envelope power. Luckily, they're not asking us much about that here. Which of these would be a proper indication? A, in single sideband J3E voice mode with the transmitter keyed but without speaking into the microphone, power output is indicated. Okay, is that proper? Should there be some sort of power output? I suppose it depends on the system. But even with this one here, if I'm not talking, it's still picking up a little bit of the background noise. So, but if there was no background noise, perhaps there would not be any type of power output indicated. In Cytor communications, the power meter can be seen fluctuating regularly from 0 to the 60 watt relative output reading. All right, it is a 60 watt system, so it goes from 0 to 60. What is Cytor? I've got that above. That's simplex teletype over radio. It's a system for transmitting text messages. And it seems like we have a number of those. We've already hit on a couple earlier. And there's going to be a couple down the road. It was developed in the 1960s. It was an improvement over radio teletype. So it's a way of transmitting a text message. So would the meter go from 0 to 60? I suppose during the pauses it might be at 0. And during the transmission of the text messages, it would pop up to, I guess, the 60 watt level. That could be a proper indication. So far they both look proper. C, in SSB, J3E mode, again, that's voice. Speaking into the microphone causes the power meter to fluctuate slightly around the 60 watt reading. So again, if I'm speaking into the microphone, is it going to be at maximum? Well, probably not. I think maximum is way up here, and maybe that's proper. Maybe I'm speaking really loud. That may be improper, though. Or D, a steady indication of transmitted energy on an RF power meter, which I defined above, with no fluctuations when speaking into the microphone. So a steady indication, meaning it's kind of a flat line that you are transmitting energy while speaking. Well, you're probably, I don't know. This one is hard to say. An RF power meter, though, is an instrument that can measure the electrical power mostly in the range of 100 megahertz to 40 gigahertz. This meter consists of an RF power sensor that is connected to it via a cable and can display power reading. All right, I see one person did answer. And we're looking for the proper operation. I like B also, now that you've focused me in on it. Yes, it is the text type of communication, and you probably are going to see a fluctuation from 0 to 60. A fluctuation around the maximum, that's probably not correct. It should, even in voice, it should go from maybe 20 to 50 or something like that. And apparently, well, let's see if we're right. It is the correct answer. What's wrong with A? Basically eliminate the incorrect answer. A, the proper operating transmitter would show no power output if there's no modulation of the microphone. So it's not going to show anything if it's operating properly and you don't have any background noise. Answer C, power output during modulation should return to 0 watts during the pauses. So we've got that one correct also. And D, saying hello into the microphone without anything else going on, seeing the meter pegged at 60 watts equals feedback, apparently, I guess. All right. Answer B is correct. And the final question, which I was starting to work on even as class started, but basically, this one I guess is kind of a MacGyver question. The only fact that so far I was able to throw together just to at least start us in the right direction is basically talking about the length of radio waves that are traveling through the air. And if you did have a yardstick, or in this case, a meter stick, which is a few inches longer than a yardstick, and you can actually hold it up and measure the radio wave as it's from one peak to another peak, or one valley to the other valley, and that measurement it can be measured at if the frequency is really high, the waves are going to be bunched together so much that it may only be less than an inch between the radio waves. But in the VHF high frequency spectrum, the length is apparently between 1 and 10 meters, which would be the equivalent of, well, if we're talking feet, I'm sorry, yeah, we're talking feet. 1 meter is a little over 3 feet, so it would be 38 feet. If I got that correctly, no, it'd be more like 31 feet, 32 feet at the high part of the spectrum, and only 3 feet at the low part. All right, let's say 3 to 30, which is the same as the megahertz in the VHF. Well, 30 to 300. So strike that. All right, let's see what else we have. An antenna tuner, I attempt to explain that a little bit because each one has the word antenna tuner in it. So there's going to be something wrong with the antenna tuner. It's an electronic device in the feed line between the antenna and the transmission line, and its power is to optimize the power by matching the impedance of the radio to the impedance of the end of the feed line, connecting the antenna to the transmitter. And that's in effect an antenna science, and that's the main thing they do. They read the impedance and basically use inductors or capacitors to turn that impedance or to basically equalize it to find resonance, which are electrical terms, which you may or may not have already seen. Did I already share the results? I'm just going to relaunch the poll. Your antenna tuner becomes totally inoperative. What would you do to obtain an operation on both the 8 megahertz and the 22 megahertz frequency bands? All right, so basically they want you to turn into a MacGyver a little bit. Your antenna tuner is messed up, so all you have is an antenna. How are you going to actually transmit or operate on a frequency which is in the VHF band? It is 3 to 30. It's 30 to 300. So I guess this is in the high frequency, isn't it? Because it's under 30. All right, so maybe my explanation isn't going to really help you. So what do you do in order to operate the radio? A, without an operating antenna tuner, transmission is impossible. B, it is impossible to obtain operation on 2 different HF bands without an operating antenna tuner. So they are 8 high frequency bands. Or C, do you bypass the antenna tuner and shorten the whip to 15 feet? You might already kind of catch the clue of what I'm trying to hint at, is that the antenna basically corresponds with the size of the wave that you're trying to decipher that's flying through the air. So if your antenna is the same size as the wave, you're going to be able to read that frequency. So without an antenna tuner, your antenna is going to read one frequency and that's it. It's the one that corresponds with its size. So do you shorten the whip to 15 feet? Or do you bypass the antenna tuner, use a straight whip or wire antenna, which is approximately 30 feet long? And I don't know if you remember the TV show MacGyver, but you want to get to those frequencies, um, you'll basically have to know approximately the length of the wave. And so it's going to be basically one or the other. Are you going to shorten to 15 or are you going to increase to 30 in order to hit the right frequency band? I was struggling with how to even explain this question. It's one of the more difficult questions in Element 1. What do the books say the answer is? They're saying it's D. Apparently, you can use a dipole with each leg approximately 30 feet long or a 30-foot wire counterpoised off the metal of your vessel. This antenna has double resonant points, and most single sideband marine transceivers will output a fair amount of power even without an elevated standing wave ratio, which I guess we are briefly talking about that. Just because your automatic antenna tuner is not functioning, don't think that your radio station is off the air. Develop your own resident antenna system and get back on the air. Right. So you're going to have to know that in order to pass Element 1. Not really. Basically, you're going to have to use a little bit of a discernment, and it maybe I can get a better explanation down the road, but at this point, basically, you're going to bypass the antenna tuner and apparently put a wire out that's 30 feet long in its place. All right, that's going to wrap it up for me. Let me stop.